Hi friends, welcome back to another episode of Ryan's Routing Table. My name is Ryan, and today we're doing another episode of our Networking 101 series. Today we're going to talk about ARP. We're going to talk about why it exists, what problem is it solving for, and I hope you learn a little something here. So without further ado, let's jump right into this thing. The first question is, what is ARP? ARP stands for Address Resolution Protocol, and it's how devices find each other on a network. So what problem does ARP actually solve here? On a local area network, or a LAN, devices deliver frames using MAC addresses, not using IP addresses. So your device knows the destination's IP, but it needs the matching MAC address to actually send the frame. So the problem is that we're talking in two different languages here. With an IP address, we're working in the network layer, layer 3 of the OSI model. You can check out my video on the OSI model, which is episode 1 of this series, actually, if you haven't checked that out. IP addresses are used to route between different networks. And this is an example of what an IP address looks like. A MAC address lives at the layer 2, which is the data link layer, and it's used for local delivery. And this is an example of what a MAC address looks like. The problem is that a device knows the destination's IP address, but for local delivery, it needs to know what the MAC address is. And ARP is how it puts those two together. And this is how ARP works. Step 1, a device broadcasts an ARP request to the whole LAN. Something like, who has IP 192.168.1.5? Tell 192.168.1.10. So it's broadcasting its own IP address, saying, hey, let me know who has this address. The step 2 is the reply. Whichever device has that IP address replies directly back to the sender with its own MAC address. And then step 3, the requesting device then stores this pairing in its ARP cache or ARP table for future use. Because step 2 is a direct reply to the sender requesting the MAC address, every device is going to have to go through its own ARP process to find the MAC address of each device on the network. And it's going to have to build its own ARP table as well. But this ARP table is used to cache addresses for future use so that you're not having to continuously send out ARP requests and ARP replies. And this is what an ARP cache looks like. It's basically just a very simple table associating an IP address with the MAC address of the device, and type meaning dynamic or static. Caching avoids repeating broadcasts for every packet, and entries do expire and are refreshed automatically just to make sure that nothing changes. If an IP address changes, they want to make sure that the MAC address reflects that as well. And you can actually try this yourself. If you go into the command line or the terminal of your computer right now, and you can type ARP-A, you can see the ARP table in your own system, which is really interesting. All right, so what did we learn today? We learned that Address Resolution Protocol translates a known IP address into the matching MAC address on a local network. It starts with a request being broadcast to the entire network, a reply being sent directly to the requester, and then that MAC address being cached for future use. In my next episode, we'll be talking about both DNS and DHCP, and we're going to cover how your computer finds anything by name at all. So that should be fun. I appreciate you all joining me. Thank you so much. I hope you learned a little something today. And if you liked the video, go ahead and give it a like, send me a subscribe, comment, do all the things. I appreciate you, and I'll see you in the next one.